Welcome to this first chapter on how to code models, architectural models. We will start with a very simple principle setup to get an understanding how the interplay of the lambda calculus and architectural models or computer graphics can be organized and can be seen. So let's go here. First chapter. So we always start with numbers. So in this case, we say we can look here, see what it is producing. You see this is a list of coordinates. And this is run by D1. Look at this. So range 12 gives you a list of 12 numbers. Range 6 then is a list of 6 numbers. So in tuples simply combines, so it's a combinatorics of these two lists. And by that it's 72 numbers and as these pairs. So go for chords, ask for that. So these are all the pairs, and then ask for the length of it. And then we have 72 numbers in all combinations. So this is the geometrical setup. These are the numbers. So we can render this as a graphics. So therefore we have a renderer. It's called graphics. We say all these coordinates, for each of them apply this pure function. So each of the coordinates, step by step, put it to this asterisk, make a point, blue, go for the second coordinate, point, blue, and so on. This is the body of the graphics. So 72 points. Then we have here some options, image size and plot range, to make it a proper appearance. And we call that, assign that to a G1. And here we have a grid of 72 blue points. So this is simple. So now I can select certain points. So interesting now is that this is a G1 is a data structure. It's rendered like this, but I can ask what is it? What is the body of G1? So therefore skip the operation on rendering and look for what should be rendered. This is done with give me the first element of G1. So give me the body of G1. And then he says, the cloud, it's always a little tricky. So here we have, so he doesn't like these images of the colors. So, and here we have all our points. So this is what this operation here, this function did. We filled all these elements here, points, colors, blue, and so on. And this is rendered by the graphics command. So this is the first element is exactly this here. This is what we are asking. Okay, so if we have that, now we can produce our keys and we can ask G1 for all points. So the key should be this here, all points where x is 3 and y is variable, any y. So now we can ask, so this matches to all these points because the points of 1, 1 will not match. But this one will match. Point of 3, 5 will match. So if we go here, then we get the points of 3. So that's very interesting because we can, so you see these graphics is not pixels, it's alive because it's always the code. So therefore we can ask and select certain parts. So we can ask, what is this with 3, with 2? Or we can ask, What is it if we put here A, and then we ask with A smaller, we can say 2 smaller A smaller 5. Then we get 3 points with 3 with 4, and that's it. So we get these points. Good, but we had the 3. So this is very important. So we never go for lines and things. We just keep the code, and we can operate on the code. For example, select elements, which is a very key feature of building information models. So taking that, we can choose another a function which is a kind of sibling to cases. It's called replace. So when we say G1, again, we look at G1, replace, and then we say whatever list is, we take whatever is here, we take a list, you see. Then we have point, X, and Y. So whatever is here, in our case, it's only the color. And if 2 is smaller than X, smaller than 8, and 2 is smaller than Y, smaller than 5, make it red, point size 0.3, and make a point of X and Y, so take the variables and make this and replace the original one, so the blue, with a red with bigger size on the same position, and make that on all layers, on all levels within the graphics 1, and assign that to graphics 2. So look what happens. Here we are. So we are able to replace and change the graphics with a key and a new production. So we can make subgraphics. So, for example, we can say if this G2 is this graphics, we can say delete cases, another sibling of these functions like replace and cases, and it's working very similar. So again, we have G2, so it's this one. We ask whatever it is, point XY, whatever is coming, nothing or a list of other things. If X is greater than 5, and do that on the level of 3, or I think we can put that with all to make no confusion. But I don't need to explain that. So then we delete everything which is X, all points X greater than 5, and make that a subgraphic. So then we see this is a subgraphic of G2. We would be able to assign it to G3. But that's it, a subgraphic. And of course now we can do similar things. So for example, we can do counting. This is what we are interested in. We can ask, oh, let's make that G3. So we can ask cases. Now whatever, if they are red, and point whatever is in there. So we count all the reds in this case and ask how many are there. So, and then we say there's 10 of the reds here. If we go for blue, we have 62. If we go for G3, then we see it's 24. And if we go for red in G3, it's 6. So this is counting. Very important things. Or, just for fun, we can translate a two-dimensional graphics because it's just around, it's a certain structure what we have. Yeah? It's our structure we had with the tuples here. And then we added more attributes to make this graphics here. We added attributes here and made it more diverse. And then we made a for example, one floor or a certain section or whatever. So we can select, we can count, and we can make it 3D. Look at this. So we go for replace G1, and now we want to see the code. Therefore, we don't keep we don't keep the renderer because you have to change the renderer to G3. We will do it later. So therefore, it just takes the code and look at code. So then we say replace, and we have multiple replacement rules. So it's one. We want to have the red points to red spheres x and y, and z is 0 with a radius of 2. And if there's a blue point x and y, we want to have an edge form. So don't show the edges, just the faces. Make it gray and make a cuboid at x and y 0 minus 0.1. So it's a little offset, and plus offset. Make a cuboid and then look at what's happening. So we get here the code, 3D code from the same numbers, matching on our specifications here. We just make another rendering. It looks like this. We assigned it to a small G1. And now we render it as 3D, G, boxed fold, lightning neutral, and here we are in 3D. Something you can't do in CAD. So it's extremely simple. You see that? We don't need any kind of setup, very few rules to produce a data set and render it, transform it, select it, count it, all the things we need. But this is a way how to model graphics for architects. I think this was impressive enough that you find interest for the next in-depth chapter on architectural models. Thanks for watching.